All right, so today we're going to be talking about preparing alkynes, right? Alkynes are carbon compounds that have these triple bonds in them, right? So first we're going to start off comparing the acidity of alkanes, alkenes, and alkynes, right? The pKa for an alkane is generally about 50. For an alkene, it's about 45. And for an alkyne, we have a big drastic jump all the way down to 25, okay? Alkynes are a lot more acidic than alkanes and alkenes, making them more reactive with bases. That means that this hydrogen right here is going to be more willing to just be donated off and be pulled off by a base. So we see these with the formation of alkene reactions, starting with your simple alkyne just looks like this. Hydrogen on both sides, and basically we're going to use this base, and this is true for all the alkyne reactions. So this is how you can like see right away, oh, this is probably going to involve some sort of alkyne reaction. If we use NaNH2, okay? Of course, this dissociates in solution. We're going to get a positive charge on Na, and we're going to get a minus charge on NH2, so it's going to be NH2 minus, and NH2 minus is going to pull off a hydrogen. Right? Acid-base reaction, this is your typical proton transfer, and that's how that looks. So then our product to that looks like this, and we now have an anion on our carbon, right? Now this compound is a really strong nucleophile. It's also a really good base, okay? But just focusing on the fact that it's a strong nucleophile, it can also take part in SN2 reactions, right? That's one of the things we learned about SN2 reactions, that strong nucleophiles are necessary, right? So what can react in an SN2 reaction? Something that's very willing to react are primary, secondary carbon compounds, right? Alkyl halides, etc. So we're going to be using this Br, and then take a second to think about where this is going to add and how this alkyne will look at the end, okay? Here's how it looks. You still have your hydrogen there, carbon triple bonded to carbon, and then we have to count our carbons on this that it's going to add to. Okay, so 1, 2, 3. So we're going to have 3 carbons attached to this carbon. 1, 2, 3. Just like that. Okay. The way this mechanism looks is just like your typical SN2 mechanism. Your nucleophile attacks from the back of that carbon, kicks off bromine, and that's your product. So you also have Br minus as a byproduct. Okay. So the other thing that can happen here is that you can also get NH2 minus to react with this hydrogen right here again. And that hydrogen can then be pulled off, and then we can also add another alkyl halide, do another SN2 reaction, and carry that forward to form an alkyne that has carbon chains on both sides. Okay? So yeah, that's just your typical SN2 reaction with alkynes. Now we're going to learn about preparing the alkyne itself from alkanes, okay? So in the past, we've learned E2 reactions always start off with something that looks something like this. And then we add OH minus or NaOH, and we'll always get an alkene, okay? Now we need to take it a step further to get an alkyne. How do we do that? We do 2 E2 reactions, right? So this is E2. So now we need to do 2 E2 reactions in order to get an alkyne. So here's how that's going to look. We can either get this alkyl halide, so 2 bromines, and that's where the triple bond is going to form, or we can have the bromines here instead. Br there, Br there, and then both of these will react with our base for alkynes, okay, NaNH2, always used for alkynes. So NaNH2 is going to go over here, 2, and that's going to do 2 E2 reactions here, and in the top, we're going to get that triple bond, sorry. It's actually going to look, has to be straight, so it's going to look like this. Just like that, okay? This carbon right here is that carbon right there. Here, I'll even color code it. This carbon right here is this carbon right there, and this carbon, we'll do this in orange, right here is that carbon right there, okay? And what happened in here is that it's the same carbons. There, and in green, it's there as well, okay? Where this may get tricky is if we have two starting materials that look like this, okay? So first one you get looks like this, and we have a BR here, and a BR here. Or our other starting material will look like this. 1, 2, 3, 4, 5. With 2 BRs over here. BR, like so, okay? Now, if we react both of these with Na and H2, do you think we'll get the same product? NaNH2. The answer is no. You don't get the same product in each because in this starting material, you actually get 2 different products, right? Your first product, so first let's work out this product and let's see what it will look like. So 1, 2, 3, 4, then we have our triple bond form and 5 carbons, and that's it, okay? In this compound, in this starting material, we also do get that product. However, we also get a byproduct that we don't want. So we also get something that looks like this. Like that. And that's not desirable. So because we get these two, because the way, just the nature of an E2 reaction is you can pull hydrogens from opposite sides, we get these 2 products, and that's not desirable with a starting material. So if we do need a selective alkyne, we need to use something like this where we have bromines on the adjacent hydrogens so that we do for sure get 1 alkyne formed, okay? So just to clarify, the hydrogens that are pulled off in this reaction right here are hydrogens located here. So I'll color code this a little bit just to make this really clear to you. What these hydrogens are doing, what they're participating in. This hydrogen right here is going to be pulling off, is responsible for pulling off this bromine, while this hydrogen right here is responsible in the E2 reaction for pulling off this bromine. Okay, so these 2 E2 reactions happen to form this alkyne, while in this starting material we have hydrogens both here, hydrogen there, and over here. And this is where we get our different products. If we pull off the green hydrogens, we're going to get this product. And if we pull off the orange hydrogens, we're going to get this product. And again, this isn't the product we wanted. This was the product we wanted. So keep that in mind when you're preparing alkynes. And that's it for alkyne reactions. Thank you.